Okay, sorry. Second video. I accidentally locked my iPad and it stopped. So, we're picking up where we left off. Alright, so yesterday, I think somebody in one of our classes mentioned slope-intercept form. Okay? And that is y equals mx plus b. Okay? Now, our mx, or our m, is our slope. In other words, how many times is it going up? It's going up 3. Our common difference is 3. Okay? So we're first saying y equals 3x. Okay? Now b is normally used for the y-intercept. Okay? But in order for me to get a 20, we are going to have to use 17. That's because when we plug in a 1, we need to get a 20. 3 times 1 is 3, plus 17 is 20, okay? So, this is one equation you can use, okay? And the other one, I think, is a little bit simpler, okay? So this is where we're using that recursive definition. So that n minus 1, or you can say x minus 1. Any variable works, okay? Remember that, any variable works. So I want you to write this, make sure you write this part on your notes. So we have y equals first term plus common difference n minus 1. Or you can say x minus 1. Either one works. It's just a letter. All right, so if you look, the first term you get out when you put in a 1 is a 20. And we're bringing our stuff down. Plus, we said our common difference was 3, okay? And you're just dropping down that n minus 1, okay? Now, if I started plugging in row 1, row 2, row 3, row 4, row 5, row whatever, into this n, we would get out the term, okay? So let's just try 6. We are looking for f of 6. So I've got a 20 plus 3 times 6 minus 1. So we have to simplify, right? We have to use, please excuse my dear Aunt Sally. So first, I'm saying f of 6 equals 20 plus 3 times 6 minus 1 is 5, okay? So now we simplify. 20 plus 15 equals 35. And in number 3, we wrote row number 6 has 35 seats. Okay? So that's exactly what that means. All right. All right, on number 5, okay, right here, it says what kind of sequence is generated by the number of seats? Well, what are we learning today? We're not learning about geometric. We're learning about arithmetic. So we have arithmetic sequence, okay? How do we know that? We know that because the common difference is 3. This means it goes up by 3 each time. Okay? Simple as that. All right, if you have questions when you start watching the video, feel free to email me, okay? I'm just going to be here video and lessons for the rest of the week today, so I'll be around, so just let me know. All right, moving on. Let's go back to Agile Mind. And I want you to click over to, if you want to click through your thing, let's see, let me zoom out. It shows you how to work everything, okay? We're playing our animation. It's just showing what I showed you. +1 on the left-hand side, +3 on the right-hand side, okay? Just showing you again the sequence and what it's doing. The rate of change of the function is the common difference of the sequence. Okay? All right. Same thing. It says, study the arithmetic sequence. The first term is denoted to be 20. The sixth term is 35. What is 4? Well, if you look, row number 4, you get 29. Okay? It says you know that each term in this sequence is 3 more than the previous term. More formally, if t of n represents the nth term in the sequence and t minus 1 represents the previous term, then the sequence is that function. Okay, let me get my pen up. All right, right here, you see n minus 1. Here, you see n minus 1, okay? No, it's not directly beside the t, okay? It's below it, but that still means your recursive definition. And if you look, it says the term previous, okay? So that's what that means, previous. All right. Let's see. The recursive definition is easy to understand, but it has limitations. For example, if you want to find the 100th term in the sequence, you will need to find every one of the first 99 terms in the sequence. So you have to know all terms leading up to what you're looking for. Okay? All right, we're on question 6, okay? On the Agile Mind, it says, is there another way to find any term in the sequence